Hello, Massimo. Welcome.
Hi, Barbara.
Thank you so much for joining me here today.
My pleasure.
So let me start by asking you, I hear that you're into windsurfing, running, biking. Where do you find the time? Because I know you have a pretty packed, busy schedule.
Yeah, in fact, I don't find the time for doing everything I wish. But two things. First of all, running is good for people traveling a lot because you find yourself in places where you can't sleep and you can go running early in the morning. Maybe not really safe, but still good for training. I wasn't born as an early bird, but I learned how to become an early bird. And I take some time for myself in the morning before starting my activities.
Sounds very healthy. Very good. So Massimo, the age of electricity is upon us. What does this really mean for the demands and challenges facing utilities and grid operators in 2026 and beyond 2026?
Certainly also beyond 26 is a decades thing. Look, first of all, we all see that there is a huge increase of demand of energy overall in a society. Some analysts say it's about 20% in the next decade. Whereas some project the increase of demand of electricity up to 70%. Which means not only a lot of this increase of demand of energy will be covered with electricity, but a lot of what is today provided with other forms of energy, typically molecules, will be transformed into electricity demand. So that is what typically we refer to as the energy transformation. And where is this growth coming from? It's coming from the electrification of mobility. It's coming from the electrification of heat pumps. It's coming from the electrification of several processes in the industries. And now we have the big data centers, which of course will take a huge amount of extra demand of power and electricity. So all of this increase can only be served if you expand the system in terms of generation of electricity and in terms of transmission and distribution of electricity. And the whole transformation involves the whole system, involves particularly the grid at transmission and distribution level, in that it has to transport and distribute this huge amount of extra electricity. And so the huge investment which is going to the grid is and the era of electricity is because of this transformation impacting essentially the overall electrical system across basically all geographies. And this doesn't come only with main gear, doesn't come only with transformers, with high voltage equipment, and with solar panels and other equipment to generate. It comes also with huge investment in digital technologies that are needed to run this very complex and ever increasing system. And this is also why, by the way, same analysts are projecting a much higher pace of increase of investment in digital than in the main equipment and gear and CapEx equipment in the next decades. And this is not just software, just to be clear. When we talk about digital and the need of digital in order to run this complex system, we are talking about all layers, which go from the distributed intelligence, the devices which are used at the edge of the grid to protect and automate equipment. This involves the communication systems, which have to transport information across all this distributed system, and all the layers of software which come on top, which are needed to automate and coordinate this complex system, but also to run it, to manage the huge amount of assets which are distributed, and also to manage the economics of it, the trading of electricity into the markets, for instance. So it's a very complex ecosystem where digital will have an increasing role in future because it's needed in order to run this complex system.
And going on that chain of thought, how is Hitachi Energy positioning grid automation to lead this transition?
That's a quite interesting question, Barbara, in that grid automation comes from several years of merging and adding pieces to our portfolio. As an overall company, Hitachi Energy in the various forms and shapes before, and grid automation being part of it, we have been there for 120 plus years. And we have seen it all in terms of all the different technologies and different ways of generating, transporting, distributing, using electricity and protecting the equipment. But also we have started adding various components and pieces. From the protection, we moved to the automation of the entire grid. We moved to the software to manage the assets. We moved to the software to trade aspects of revenues which are related to the energy system. And in that sense, our engineers have now a very broad competence across all the aspects which are related to the energy system, and particularly to the grid system, from the planning phase of it to the build, so the construction, to the operation and maintenance, and up to the financial aspects, so the participation to the energy markets. And the way we position grid automation, we want to grow the business of grid automation, is really to help our customers cover horizontally all the various phases of their processes, from the planning to the trading, and vertically from the various layers of technology, which, as I said, go from the distributed intelligence, the edge intelligence or the edge automation devices, all the way up to the most sophisticated softwares which our customers will use in order to trade their assets.
And looking at your customers, do they have the same requirements worldwide, or do you find that the requirements change depending on what region they're in?
I think the answer is a bit articulated here. I believe that if you look at the underlying topic, so the energy transformation, the transformation of the energy system, the grid, etc., we see that the trends are the very same across all geographies. Okay. So we see more and more electrification everywhere. We see the addition of renewables and the replacement of fossil fuels with renewables a little bit everywhere. Of course, certain places may be a little bit less or a little bit more depending on the policies. And we see the same need of digitizing the assets and using a lot of intelligence in order to manage this whole complexity. So that is a little bit everywhere. I would say that there are differences in terms of the pace of adoption and the phase at which different regions are in terms of their journey into the energy transformation. So in some countries, maybe we see a lot more penetration of renewables, like Europe, of course, has invested in the last decade heavily in this sense, and of course it's ahead other regions when it comes to that transformation, but also when it comes to facing all the issues that come with that, and having to cope with that and deal with that. And then we have other regions which may be lagging a little bit behind, but they are coming up. All of them are investing heavily in this direction. The second aspect, which may be different, is policies. Policies are impacting both the speed and the way this whole transformation is implemented, but they are also impacting policies and regulations. They are impacting also the way certain things are implemented. Particularly, for instance, you have a huge difference in markets where still the system is very regulated, versus markets where it has been heavily deregulated, and where, of course, you go from top-down implementation of certain policies because they are mandated by the regulator. And for instance, if I mention the fast implementation of reliability management and asset performance management in China because it's mandated by the government, versus other regions where this is not mandated. They are, deregulated markets where everything is decided based on return of investment. And so you may see different pace of adoption depending on if certain technology make the business case or not. But the tendency is the same a little bit everywhere. The speed may be a little bit different.
Digital is often referred to as the brain of technology. How do you feel about that nickname, the digital brain?
Well, I think, first of all, I don't necessarily fully agree with the fact that digital is the brain. I think that digital is the nervous system more than the brain of the grid, at least, generally of very complex processes. at the end, the grid and the energy system is a process. The thing is not much different if you go into a big petrochemical complex in terms of having, on one hand, equipment and processes to run, and on the other hand, some means and ways to manage this whole thing. Actually, the means and ways is the nervous system, which is the digital system, and that digital system is made of sensors, is made of local devices, local actuators, is made of communication networks that bring information across the whole system and vertically to the various layers of intelligence. And then, yes, there is some level of intelligence on the top, which is meant to automate processes that cannot be managed manually because of the complexity, size, speed. And that level of intelligence is what typically people refer to the brain. Right. But let's be clear, if you have a brain but you don't have the capability to act and to sense, that's not particularly useful. So this is why I'm saying digital is not just the brain, it's the overall system.
And looking at the system in its entirety, then, enters artificial intelligence, a big topic at the moment. In practical terms, where would you say AI fits?
I think there's a bit of hype in the artificial intelligence at the moment, of course. But at the same time, a little bit like we see it happening in everyday's life, you start seeing practical applications of artificial intelligence a little bit in different parts, or a little bit everywhere in the energetic systems, which include, of course, the grid. Now, we have to be clear that artificial intelligence has been there for many years, and there are already practical applications of utilization of machine learning in various algorithms which are used at the edge to run very complex automation functions, for instance. That has been there for many years, and we, for instance, utilize similar applications in order to optimize some of our electrical protection algorithms. But of course, with what has happened more recently, with the increase of computing power, with the introduction of Gen AI and agentic, etc., of course, we have seen more and more and more opportunities to apply this to real cases. Let me mention a couple of them. We, for instance, today utilize artificial intelligence and machine learning algorithms quite regularly in systems like, for instance, in our case, we have a software called Nostradamus AI, which is well integrated with the various type of software we have in network control and in our trading. And that is a software which is used for forecasting, for prediction of, for instance, the load at a certain part of the grid, or to forecast the price of the electricity in a certain moment of the day at a certain point into the grid. All information that are needed and are basically ingested by softwares like the planning tools of our customers, which we also provide, in order to decide, for instance, if at a certain point in the day they have to commit a certain production unit to the market, or maybe that's not convenient, it's better to commit another production unit. So there are really practical applications in that specific field. Another application is where we are collaborating with startups and artificial intelligence companies in order to simulate the behavior of equipment and understand if this equipment is working according to specifications, or if it is developing any specific failure. And that is used, for instance, in our asset prediction, asset performance management softwares, in order to give guidance to the operators where to drive their maintenance activities in order to reduce the risk of a catastrophic failure of certain equipment, like big transformers, for instance. So these are very practical. Now, agentic AI is also becoming very, very trending, and where we see that more and more applied is in transactional systems like asset management or asset performance, but also in the control room, in that level of intelligence can help operators or can help people utilizing this software to automate certain processes. And basically it's the machine now that at a certain point starts taking activities that otherwise would be done by the operator clicking several different functions, and instead this is basically already emulated and done by the machine. Of course, you can reach levels where you can imagine a complete autonomous system. I believe this is not where we are immediately going. We are going more into support systems, so adding intelligence to the software to help operators expedite their day-to-day activities.
Right, and you mentioned network control there in your answer a couple of times. Why are investments picking up when it comes to network controls?
The network control systems are very sophisticated software systems which are utilized to run either the transmission or the distribution grid. I said already that both transmission and distribution grid are becoming increasingly complex, larger, but also these are systems which are affected by the energy transformation, in that basically the grid is where the energy equation has to be kept in balance. You need to keep generation and the demand in check in order to keep the frequency. And this with the reduction of fossil generation units is becoming a more complex problem, because you are taking out the big power plants which were creating inertia into the grid, and now the inertia being reduced, the grid is becoming more and more unstable. So you need to act more and more quickly, switching power from one line to another, opening or closing breakers or stuff like that. So with the transmission grid, which is becoming more and more complex and larger, first of all, there is an opportunity for the utilities to rejuvenate the softwares which have been there, sitting there for decades, running the simplest version of the grid. And those softwares, by the way, would not make it to expand and be able to run a more complex version. Then you also need to start introducing particularly sophisticated algorithms and new functionalities which were not needed before, like WAMPs, for instance, which is basically a software capable of understanding if there is instability in some part of the grid. These software were not needed before. They are becoming necessary in future to run the grid. So that is what drives the investment. Bigger complexity, larger, you need to renovate the systems, but also you need to add capabilities and functionalities that weren't needed before, are available today, and they are needed in future. When it comes to the distribution grid, think in terms of the amount of points of consumption which are added because of course, the urbanization, so more and more people living in cities, the system at the edge becoming therefore more complex, more consumption because of e-vehicles and so on and so forth. So if that system doesn't work, the damage both to people and economically is becoming much bigger. You cannot operate that system manually anymore. You cannot send people to check where a failure is. When there is also another aspect, which is the environmental situation has become a lot more unstable, and hurricanes and the big events are hitting these systems heavily, to the point that you may have tens of thousands of points into a big city which are affected. And so you need a system which is able to understand where the failure is able to clear the failure potentially faster, but also is able to give information to the operators where to send crews and people in order to repair. And all of that investment is needed at this point. You cannot run that distribution network anymore without such software support.
Then as this grid becomes increasingly digitalized, how are you addressing cybersecurity? That must be a concern.
It is. It is at all levels, and we have seen a number of attacks with potentially catastrophic consequences. I would say cybersecurity becomes really a weapon, both in terms of economic terms and in terms also of security. So we as a company, as Hitachi Energy, and by the way, everybody who is in this sector needs to take that extremely serious. It is not just one thing that you have to do. In reality, you have to act at all layers in the various processes which are bringing to online this very complex systems. The first is all our products contain software and are prone, as every product which contains software, to potential attacks. The fact that they are also all more and more connected makes this problem even bigger, because as long as they were isolated pieces with some software, the problem was relatively little, but now they are all connected and therefore they could be accessed by a potential actor which is attacking the system. So ensuring from the R&D and the release standpoint that this various components are well protected, they have, let's say, the maximum degree possible of protection to potential attacks, and they don't contain bugs or they don't contain backdoors, etc. This is a full responsibility of the vendor. And what we do is we do very extensive tests of this equipment before releasing any of them. There are standards, IEC, ISO standards, and we follow fully the maximum degree of these standards in our internal testing before we release any of these products to the market. Then, of course, once you have released this to the market, you execute projects. And when you execute projects, there are a huge number of settings into firewalls, into networks, etc., that you need to do, where potentially you can also create other problems. So there is an entire layer of defining rules and the certifications for the executing units, so that whenever they execute a project, they go through specific checklist and test, etc., and don't introduce weaknesses or weak points into the overall system design, because the product may be safe, but the system design may have opened problems. And thirdly, there is something we have to do together with the customers, because once the system is installed with the customer, first of all, you may discover in a year or a few years that there is a vulnerability, and that is typically happening. But the point is, once you discover there is a vulnerability, you need to immediately find a way to close that vulnerability with a patch or an upgrade of software. But the other piece is customers, they operate these systems and they can themselves introduce other vulnerabilities or weak points. So what we do with our service units is to work together with the customers, doing audits of their systems, going extensively and understand if there are any potential weak areas, and then providing them with the proposal of solutions for hardening the overall system. So, and this is a continuous thing you have to do. It's not something you do once and you are safe forever, because in reality, these things are living, and also over time you may discover that a Windows system sitting somewhere as a bug or as a vulnerability that wasn't known the time you delivered it.
Right, I've just got a couple more questions. Data centers and AI are all over the news most days. How should utilities go about that demand? There is quite a lot of demand for those two.
The amount of power that in the next 10 years is required by particularly AI data centers is going to triple. And there's going to be an addition of, somebody say, between 100 and 150 gigawatt. It's a huge amount of power. But that's not the only point. The other point is not only you need to generate that power somewhere, you need to transport it, and you need to transport it to the point where it is consumed, which is not necessarily a point where there is a very powerful transmission line. So the first thing which this brings to utilities is planning. So to build the gigantic data centers that somebody is willing to and committing to build today will require certain utilities to plan and commit to transport a huge amount of power, talking about sometimes gigawatt, to a certain location where today there might not be a transmission line or not with such capacity. And that is a big problem per se, because planning is not something that you can do very quickly. And by the way, as you probably have seen, all these commitments are to build very fast, these data centers, with the speed which is definitely not the speed that you can build this energy system at the same pace. So some of this, for instance, are built with microgrids, which are big power plants built just next to the big data center, because at least for the next few years, they know they need to basically generate the power for themselves. But the second very important thing is, differently than the more traditional data centers that were built in the past, which were operated at a relatively stable load, the AI data centers are working with the big swings of their load. Because during certain phases of learning and certain phases of inference, the power consumed by the data center can swing by a huge amount. Percentage-wise, sometimes tens of percentage points of difference between base load and the peak load. And of course, this is not good for the grid, because the grid in the energy system doesn't like a sudden increase of power, a sudden decrease of power. Somebody needs to compensate this somewhere. Right. And so what this brings is the need to find ways to either smooth this whole operation of the data centers, distributing it over time or over different locations. And that is a big thing that data centers people and utilities are already thinking. But the other thing is you need to create some buffers somewhere. And so some utilities or some operators of data center are thinking about big battery storage systems, for instance, that will absorb these peaks. And this is a very huge investment, very huge projects that need to be added in order to be able to cope from a grid standpoint to the operation and consumption of a data center, of an AI large data center, not any data center.
So my last question to you is, so this is the first episode of the Grid Automation season of the Power Pulse podcast. We're talking about all things digital across the board. What is it, the one takeaway that you would like the audience to leave with from your episode? And if you were to introduce the rest of the season, what would you say they should expect of episodes to come?
Well, on the first thing, I guess by now you understood that when we speak about digital in grid automation and digital for the grid, we don't just see one piece or one small slice. And I'm convinced this is the way we are driving our business, that the overall transformation of the energy system requires digital to be mastered, in both dimensions, horizontally and vertically across the various phases of the life cycle of the energy system itself, from the planning to the trading, and vertically in terms of the various layers of technology, as I said before, which are involved. And what I would like the audience to take away is that Hitachi Energy Grid Automation is a good partner, and our aim is, because we have over several years built engineering competencies across, and we understand the way the business is operated by our customers. We understand the physics, we understand the various technological issues, and we have a lot of support also from the Hitachi group to understand and master the digital technologies. So because of that, we believe that we are very well positioned to support customers to go through the journey, because they will not solve the problem just by solving one piece of that equation. They need to probably cover everything from left to right and from bottom to top. And we can help a lot in that respect. And when it comes to the next episodes, which frankly, I don't know the plan myself, but I think there is a lot of specific know-how, which is with my teams. And what I really would like to convey is how much competence and passion is needed to drive this overall topic. And that is, for me, a very distinctive thing of this industry. The passion which drives the people into this business, and the speed at which they are working and continuously renovating the technology, the solutions, etc. It's spanning so wide and so broad that I couldn't say myself, which one piece would be more or less relevant. But I guess at least they should expect people to express a lot of passion for what they're doing.
It'll be worth a listen.
And that is very genuine.
Thank you so much for coming in today. It's been wonderful chatting with you.
Thank you very much, Barbara. It was nice being here.
Thanks
a lot for having me.